Hello, welcome back. My name is Burkhard Schipper. I'm an Associate Professor of Economics at the University of California in Davis, and I teach you Intermediate Microeconomics. Today I will talk about Chapter 1, which is called the market. Economists do it with beautiful models every day. No, not what you think. We do it with mathematical models that are equally beautiful though. What is a model? Well, a model is a simplified representation of reality. What is this? And why would it be useful? Well, perhaps you still remember your first day on campus when you tried to look for lecture halls. You may have used a campus map. Something like this. Now, a campus map is a simplified representation of the campus. And because it's simplified, it's actually useful because it can help us to find the places we want. If the campus map would be as big as the campus itself, it wouldn't be simplified in this case, then it wouldn't be very useful because already unfolding it would be very impractical. Now, with economic models, it is very, very similar. They are simplified mathematical representations of reality. And because they are simplified, they allow us to analyze complicated economic problems that we couldn't analyze in full complexity. One of the models that you know already pretty well from the principles of economics is the supply and demand model for one good. So in this model, we have a little diagram. On the x-axis, we write down the quantity for the good, which we denote by x. And on the y-axis, we will write down the price for this good, which we will denote by p. And then we have a demand function and the supply function. The demand function is usually downward sloping. It reflects what is called the law of demand. The higher the price, the less is demanded. So this is the demand function. And then we have a supply function, which is usually upward sloping, because the higher the price, the more firms are willing to supply. So here's the supply function. Now, what I want to ask is, what does this model has to do with reality? It's supposed to be a simplified representation of reality, of a market for one good. If you go to the farmer's market in Davis, then you don't see directly a demand function or a supply function. This is quite different from the campus map. If you look at the campus map, there you can see a building, for example, the Social Science and Humanities building, and you can try to use the map to go there. But for the farmer's market, you don't really see the demand function for bananas, let's say. So how can we derive it from reality? How is it connected to reality? In order to show how the simple model is connected to reality, I will run a little experiment. Now, experiments become more and more common in economics. Often, when we don't have data, we can run an experiment that generates the data for us. In our case, I will run a little experiment on the market for bananas in our class, let's say. So here are two bananas, and at the end of this class, these two bananas will be sold to some of you in this class. And you have to pay me, of course. Now, the way I will sell these bananas in this class is I will use a mechanism that will not only sell these bananas in this class, but it also allows us to elicit the willingness to pay for bananas of you in this class. The way it works is as follows. It's an ascending auction, essentially. So I will call out the price, and all of you who actually would be willing to pay this price for banana should raise their hand. And I will always count the hands at the particular price. And then I will slowly increase this price, and we will see how the hands are dropping. And eventually there will be just 2 hands left. And in this case, I will sell these 2 bananas to these 2 people. And well, they have to pay me the current price. So this procedure will allow us to generate the data that we need in order to draw the demand function. And I will demonstrate this now. Now, since I'm here not in my classroom, I will do this on the PowerPoint.
These are our consumers in the market. They represent our classmates that are in the market to buy eventually a banana. I think these are 17 altogether, so let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, then we want to run now our experiment, and we do this with this mechanism that I described earlier. So we will elicit willingness to pay, and we do this by I call out some price, and we write down how many people actually have their hands up, indicating that they want to buy a banana for this price. Now this we can do best with a table where we can write down the price, and we can write down the hands that are up. So here's a table, and in the first column I write down the price, which I denote by P. And in the second column we will write down the number of people that would like to buy a banana for a particular price. So this is the quantity demanded, and we indicate this by the variable x. So we start our mechanism, and we start with a very low price, namely 10 cents. So who would like to buy the banana for 10 cents? So let's see how many arms are up. Okay, almost all arms are up. We can see almost all arms except for the gentleman here down in the left. He wouldn't like to buy a banana for at least 10 cents. So we have 16 people that would like to buy the banana for 10 cents at least. Now we slowly increase the price. Here we have a higher price of 20 cents. Who would like to buy the banana for 20 cents? Okay, see, a couple of people took their hands down, the gentleman up here and the lady down here. So the others still have their arms up, and so we have 14 people left in the market that would want to buy a banana for at least 20 cents. So can increase the price further to 30 cents now. Who would like to buy the banana for 10 cents? And more people take their arm down, so let's count them quickly. Who has their arm left up? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 people are still in the market to buy a banana, and they are willing to pay at least 30 cents. We increase this further to 40 cents. Who would like to buy the banana for 40 cents? And one gentleman took the arm down, so we have now 10 people left in the market for bananas who are willing to buy at least who are willing to pay at least 40 cents. Now we increase this to 50 cents. Who would like to buy the banana for 50 cents? And nothing happens. So all the people that would be willing to pay 40 cents are also willing to pay 50 cents. So there are still 10 people left in the market. And now we increase further to 60 cents. who would buy the banana for 60 cents? And actually now we have quite some dropouts here. So we have one arm up, 2, 3, 4 and 5. So 5 are still left. So this is quite a drop from 10 to 5. This may be due to the fact that on our campus they sell bananas for 50 cents. So some people that don't have an urgent need to eat a banana now in class, they may actually be willing to wait and buy a banana later for 50 cents instead paying now 60 cents or more. Okay, so this may explain the drop here. Now we increased it further to 70 cents. Who would like to buy the banana for 70 cents? And we see 2 further arms drop. So we have 3 people left in the market for bananas, here, here and here. So 3 people are left, and we increase the price further to 80 cents. Who would like to buy the banana for 80 cents? And up here the person took down the arm. So we only have 2 people left now who would like to buy the banana for at least 80 cents. And according to the mechanism that I described earlier, I will now sell the bananas to these 2 people. And okay, so these are the 2 consumers that are left. These are the 2 successful bidders. And they have to pay me now money. Okay, so they have to give me 80 cents. I will collect the money and I will basically exchange the money with them for bananas. Okay, so they get their banana. Okay, so this is how the mechanism works. This is basically how we generate the data, and we want to use now these data here to get our demand function. Okay, so we will write down, or we will draw a diagram. Okay, so here we have the x-axis, and on the x-axis we will write down the quantity demanded, or the quantities basically, x. These are these numbers here. And on the y-axis we will write down the price. Okay, these are these numbers here, so we can indicate these numbers that we have, okay, 16, 14, blah blah blah. So these numbers come from this column. They represent the number of hands up, or the number of consumers that we are willing to pay at least a certain price. And then here we have the prices that we discussed before, so from 10 to 80 cents. Now we take these pairs of price quantity combinations, so these are price quantity combinations, and simply write them down in our diagram. So at 10 cents we have 16 people, so there would be a dot here. So let's have a dot. Okay, so this is our first entry in our table, so this is the first row in our table. And now at 20 cents we have 14. That's our second row. Okay, so this represents this tuple of data, so a price quantity tuple, and we continue in this fashion. So here we have at 30 cents 11, at 40 cents 10, then it keeps 10 at 50 cents, okay, and then at 60 cents we have quite a drop to 5, and at 70 cents it drops to 3, and at 80 cents it drops to 2. So we basically transferred now the data that we have in the table into our diagram, so we don't really need the table anymore. We can get rid of it. Okay, and now if you look at these dots here, if you would connect these dots, then it would look already like a demand function somewhat. Okay, so let's connect dots. Okay, I connect all these dots. Of course, when I connect these dots, I make a certain assumption, namely that that the quantities are perfectly divisible, so that bananas are perfectly divisible. But of course, it's not really clear what it would mean that 2.5 hens would be up to buy a banana. Okay, so this is what it basically means if I connect these dots, that bananas are perfectly divisible, but bananas are discrete goods, so these dots are essentially important. But we often do this abstraction that we take goods as perfectly divisible, yeah, so this is done quite often. So when we connect these points, we basically assume that any quantity could be demanded. Okay, any quantity in between these two dots, for example. Now you also see that when we look at here these corners, we don't have any data, so we don't know what happens above 80 cents, and we don't know what happens below 10 cents. So what I will do conveniently, I will extrapolate the data so that I can connect to the x-axis and to the y-axis. Okay, so I extrapolate the data, and now basically we have our demand function. Okay, so this is now, or you see now how basically the demand function is connected to reality. It essentially is a representation of the willingness to pay of the consumers, and this is how we got this. I used a little experiment to elicit the willingness to pay, and this is how we got the demand function. Of course, when I did this, I took certain things exogenous to the problem. For example, we see here this big drop from 10 to 5, and this may be due to the fact that on the campus they sell the bananas for 50 cents, and essentially what I did not consider is that maybe the campus wants to respond to the prices in this class. If they notice that some students are willing to pay more than 50% for banana, they may want to increase prices, and then if I would elicit the data again, maybe the demand function would look different. So we took essentially prices outside our little market as exogenous. Okay, and this is often then done in economics, that we focus on a particular market and basically analyze everything with respect to this particular market, but we take other things fixed, and we assume that they are not influenced by what happens in the market that we want to analyze. The next I want to ask is, so this is the demand function, but how about supply? What would be the supply function here? Okay, so of course the only supplier in this market is actually me. So and my supply is, I only brought 2 bananas, so that's all I can supply. So no matter what you are going to pay me, okay, so no matter what price you're going to pay me, all I can supply are 2 bananas. And even if you pay me $1 million, all that I have right now is 2 bananas. So I cannot sell more than 2 bananas to you. And even if you pay me a little, I don't want to eat that many bananas by myself. And I don't want to take them back to the office, so I would be willing to sell you the banana even for less than 80 cents. So my supply is essentially very inelastic. No matter what's the price, I will supply 2 bananas. So this is the supply function. Okay, it's a vertical line indicating or reflecting the fact that the supply is very inelastic. It doesn't respond to the price. Of course, this again is an abstraction, because if you're really willing to pay me $1 million for bananas, I'm happy to bring a truckload of bananas next time, okay, and sell you lots of bananas. So in the medium or long run, the supply function may not be a vertical line as I indicate here, but it may also basically it may also have a slope like this. Okay, so again, this is an abstraction that basically means that we look at the particular time, namely the short run here, and for this the supply function may look like this. Okay, now in this picture there is a special point, namely we see that there is a point here where demand and supply intersect. So exactly at the price of 80, we have that the demand function and the supply function intersect. So this means that demand and supply is equal, and basically at 80%, 2 is demanded and 2 is supplied. And this you know from the principles of economics. From the principle of economics, you know that this is the equilibrium. Okay, so the equilibrium is described by a price-quantity pair. 80 would be the equilibrium price and 2 would be the equilibrium quantity. Now economists are obsessed with equilibrium, and maybe we want to try to figure out, what does economists or what economists appreciate about equilibrium. So we need some criterion to judge allocations, in particular also equilibrium allocations. And this criterion I will introduce next. The criterion that I want to introduce is Pareto Efficiency. It is called after Vilfredo Pareto, who is an Italian economist who lived in the 19th century from 1828 till 1923. He was also a statistician, an engineer, a pretty famous guy, and he was, I think, the successor to Walras in Lausanne. Walras is another famous economist that we will also meet in this course later. Now, what is the definition? I will define Pareto efficiency using an auxiliary definition first of Pareto improvement. What is a Pareto improvement? Well, a Pareto improvement is defined as follows. An allocation can be Pareto improved if there exists another allocation such that at least one person is better off and nobody is worse off. Okay, so this is a long sentence, so let's read it again. An allocation can be Pareto improved if there exists another allocation such that at least one person is better off and nobody is worse off. Now, in order to understand this sentence, it's maybe good to look at the structure of the sentence. So we have here an allocation can be Pareto improved, and then there is this if condition. And the first part of the if condition says that there should exist another allocation. Okay, so that if there exists another allocation. Now, if, for example, it is the case that only one allocation is possible, then this allocation can never be Pareto improved, because the if condition can never be satisfied. But if there exists another allocation, then this allocation should have two properties in order to qualify as a Pareto improvement. The first property is that at least one person is better off, and the second condition is that nobody is worse off. Okay, so these are the two conditions that we require from this other allocation that Pareto improves this allocation. Okay, now we use this definition of Pareto improvement to define what is Pareto efficiency. Okay, so here's the definition of Pareto efficiency. It says an allocation is Pareto efficient if no Pareto improvement is possible. So again, an allocation is Pareto efficient if no Pareto improvement is possible, which means that you cannot find another allocation such that at least one person is better off and nobody is worse off. Okay. We can also define now what is Pareto inefficient. An allocation is Pareto inefficient if it is possible to make somebody better off without making another person worse off. So if it's possible to find another allocation with which we can make somebody better off without making any other person worse off. So these are the definitions, so let's try to apply them in order to figure out what they actually mean. Here's an example. Okay, so the example is pretty easy. We have two objects, two goods to allocate. The first good is an apple, and the second good is a pear. Okay, so we have an apple and a pear, and now we want to allocate these two goods among people. Okay, so we need two individuals, two persons. One is N and one is Bob. And now these individuals, they have certain tastes. So N actually, she is indifferent between apples and pears. So I use this tilde to indicate that N is indifferent between apples and pears, which means she likes apples as much as pears and pears as much as apples. So she's really indifferent. She doesn't really care whether she has an apple or a pear. Now Bob has a more refined taste. He strictly prefers apples to pears. And this is indicated by this curly greater sign. Okay, so he strictly prefers apples to pears. This is what it means. So these signs we will meet later in the course quite often when we talk about preferences. Okay, but I informally introduced them here already. So Bob basically strictly prefers apples to pears. When he has the choice between an apple and a pear, he would always go for the apple. Okay. Now we want to study an allocation, and there are many ways I can allocate, or there are two ways I can allocate these objects. So let's first allocate as follows. I will give N the apple and Bob the pear. Okay. The question is this allocation Pareto efficient? Okay. Now, in order to check whether this allocation is Pareto efficient, we have to figure out whether we can find a Pareto improvement. Okay, so there's only one other way the allocation could be. Okay, so and the question is whether this other allocation that exists would be a Pareto improvement, so would satisfy these two conditions, namely that somebody is better off without making somebody worse off. Now, this other allocation would be that actually they switch, so that N would get the pear and Bob the apple. Now, this would make Bob strictly better off because he strictly prefers the apple over the pear, and it wouldn't make N worse off because she's indifferent between apples and pears. So basically, this allocation here, that N gets the apple and Bob the pear, is Pareto inefficient because we could find a Pareto improvement. There's another way we could have allocated this, so N would get the pear and Bob the apple, and in this allocation, well, this allocation is Pareto efficient because we cannot find a Pareto improvement anymore. The other allocation that is possible is the one we just discussed, and there Bob was worse off. Okay, so the second allocation is Pareto efficient, the first one is Pareto inefficient. Now let's look at another example which is a little maybe more complicated. So suppose a mother has a chocolate bar and two little kids, N and Bob. Okay, so here's a chocolate bar, and here's N and here's Bob. Now the task that the mother has is how to allocate the chocolate bar among the two kids. And one way she could allocate it is she could simply take the chocolate bar and give it to N. Okay, then N may be happy because she got the chocolate bar, and Bob may be unhappy. But the question about happiness may not be the question about Pareto efficiency. So we should check whether this allocation of by the mother that gives all the chocolate to N and to Bob nothing, whether this is Pareto efficient. Okay, so can we find the Pareto improvement? Okay, so is this allocation Pareto efficient? Can we find Pareto improvement? Now we can check whether there are other allocations. Of course, there are many other allocations, and can we find one that would make somebody better off without making somebody worse off? Now, what we could do is we could give Bob something. So we can take something away from N and give it to Bob. Now, this may make Bob better off, so he may be happy because he gets some chocolate. But N now starts to cry because she lost some part of her chocolate, and she really likes more chocolate to less chocolate. So this is often one implicit assumption we do in consumption theory, is that more is better. So preferences are monotone. It's not that if they eat too much chocolate, then their stomach is aching and they would prefer actually not so much chocolate. No. Often what we do in consumption theory, we assume that more is better, so N has monotone preferences in chocolate, so more chocolate is better for her. Now the question is whether this change in the allocation is a Pareto improvement. Okay, that is essentially no, because we make Bob better off, but we make somebody worse off, which is N. So this cannot be a Pareto improvement, because for Pareto improvement we need that nobody is worse off, and here N would be worse off. Okay. So let's look at another example. So no, let's summarize the example. Okay, so basically allocating everything to N is Pareto efficient. So even though maybe Bob is unhappy about it, but this is one Pareto efficient allocation. Okay, so we cannot make somebody better off without making somebody worse off. Okay, so this is important to understand. Now, this example also tells us that Pareto efficiency has nothing to do with fairness or equity. These are different concerns or different notions of how you want to judge maybe allocations. It also so this example also exposes an implicit assumption that we make here, is that everybody cares just about his own consumption. In this picture, in order to tell the story as I told it, if N would care, would care about the welfare of her little brother Bob, then she may be actually happy to give up some of her chocolate to Bob, because it makes Bob better off, and she cares also about how well Bob is off. But what we assume in consumption theory most of the time is that basically people care just about their own consumption. In this sense, they are egoistic. Now, economics doesn't need to make this assumption, so we can do also economics without this assumption. But for the standard consumption theory that we discuss in intermediate micro, this will be often the case, or this will be almost always the case, that people care about their own consumption, not about the consumption of others. Okay. Now let's look at another example, how we could allocate the chocolate. For example, we could give half of it to N and half of it to Bob. The question is Pareto efficient? So both are happy, they get something. Is this Pareto efficient? Yes, this allocation is Pareto efficient, because we cannot make somebody better off without making somebody worse off. So any kind of reallocation, so if we take something away from somebody and give it to somebody else, would make basically somebody worse off. Okay, because we would have to take some chocolate away from somebody. Okay, so any reallocation would make them worse off. Okay, so this allocation is also Pareto efficient. Actually, there are many allocations that are Pareto efficient, and it may be so. The lesson here is that Pareto efficiency doesn't pin down uniquely an allocation. There may be many allocations that are Pareto efficient in this example. And the second lesson is that it may be actually hard to find an allocation that is not Pareto efficient. So let's try to find an allocation that is not Pareto efficient. So what we could do is we could give 1/3 to N and 1/3 to Bob, and the other third we will put in the rubbish bin. Okay, so we wasted essentially. Now, is this allocation Pareto efficient? The question is, can we find a Pareto improvement? Well, in particular, the part of the chocolate that went to the rubbish bin, we could have given to N or to Bob, or we could have even divided it further and give some of it to N and some of it to Bob. Okay, so we wasted this, but we could have made somebody better off with it without making somebody worse off. So this allocation is not Pareto efficient. This also basically tells you that if an allocation is Pareto efficient, then there is no waste. It's not that some of the resources are basically wasted. They are given to somebody who will value it. Okay, so this allocation is not Pareto efficient. Okay, so now let's try to use the criterion of Pareto efficiency and go back to our simple market for bananas. Okay, so here we have our supply and demand function, and we can ask ourselves what would be the Pareto efficient allocation in this market. In particular, what it has to do with equilibrium. So remember, in the equilibrium, two people got the bananas, okay, and these were the people with the highest willingness to pay. So these were the people that basically had the willingness to pay of at least 80 cents, okay. So let's go back to our example, or to our picture of our market participants. So now these are the people that got the bananas, okay, so these two got the bananas. Now we could now consider an alternative allocation where we give the banana actually to somebody else, like this guy over there, okay, up there. Now we could give the banana to him, okay. Would this be Pareto improvement? Okay. Well, we can now have the following consideration. Notice that this guy, his willingness to pay was actually 10 cent per banana. Okay, so if he gets the banana, he actually is only willing to pay 10 cent for it. So then they could have a little exchange. So the guy down here and the guy up there, they could have the following little exchange, because the guy down here, his willingness to pay for a banana is at least 80 cent. So they could make a deal. You know, the guy here could say, well, look, I pay you some money and you give me the banana. Okay, so in particular I could pay 50 cents. Okay, I could pay you 50 cents. So I give you 50 cents and you give me the banana. Because look, the banana has only a value of 10 to you. Okay, but for me it's 80 cents. So if I give you 50, you are much better off, because you get 50 cents that is more than an object that you only value 10 cents. And I'm also better off because I have nothing, and I give up 50, but I get something that is worth 80 to me. Okay, so they can have a little exchange. Okay, and now actually both are strictly better off. Okay, this guy is better off because he gets something that is worth 50, only gives up something that is worth 10, and he gives up 50 but gets something that is worth 80. Okay. So we actually found another allocation that is a Pareto improvement. Okay, so this means that the earlier allocation, where we give to the guy up there the banana, where we give to the guy up there the banana, was not a Pareto improvement. Okay, and you can check any other allocation like this. Essentially, the allocation that we have in the equilibrium of this market is Pareto efficient, because any other allocation wouldn't lead to a Pareto improvement. Okay, so going back to our picture, what we just noticed is that in equilibrium we actually have a Pareto efficient allocation, and later in this course we will discuss this in much more detail. We will basically look at the relationship between Pareto efficiency and equilibrium. But here for this first chapter, we already noticed that there's a close connection between equilibrium and Pareto efficiency, and this is why basically economists are pretty enthusiastic about equilibrium and markets. Now notice, and this should come out from how we discussed Pareto efficiency, Pareto efficiency is maybe not just the only criterion that you may want to use in order to judge market allocations. So you may also think about, whether market allocations are fair, etc. But now what economists often do is they basically just look at efficiency, and if you listen to arguments by economists, you should consider this, that basically most of the time they just have efficiency in mind when they talk about markets and equilibrium. Now, okay, what I want you to remember from this class is the definition of Pareto efficiency. So I printed it here again. So please read it again. So an allocation is Pareto efficient if there does not exist another allocation in which at least one person is better off and nobody is worse off. So if I call you at night and I ask you, give me the definition of Pareto efficiency, then you should know what is the definition of Pareto efficiency, and you should also know how to apply it. So if I tell you a certain allocation, a certain situation, I ask you whether it's Pareto efficient, you should know how to judge whether it's Pareto efficient or not, because you know what is not Pareto efficiency. Yes. Okay, so that's what I wanted to tell you in these slides.
This is all for today. Please remember the definition of Pareto efficiency. Pareto efficiency is a very, very important notion, not just for economics. Thank you. See you next time. Bye-bye.